This video on plane mirrors or flat mirrors is more for background than what you will probably actually see on the AP Physics 2 test, but you never know. So let's clarify. I brought up the law of reflection a bunch of times in the last video. I want to think about how we would actually use that. If we have an object on one side of a mirror, and we want to look at that object, I have this picture up above, but I'll recreate it. We want to look at that object in the mirror. In order to determine what the light rays are doing, one strategy is to reflect the object, literally, and you hopefully learned about reflections in a geometry class, but a reflection means that you draw a perpendicular, and the segment is actually the perpendicular bisector connecting the object and the image. Now, what happens is you think you're looking behind the mirror to see the image, but you're not. What's actually happening, let me switch to solid. What's actually happening is the light, there we go, is bouncing like this. Now, I drew this in such a way that my angles here, these three angles, are all congruent, and that's necessary because we must obey the law of reflection. Again, the law of reflection says that the angle of incidence must equal the angle of reflection. And we like to measure things from the normal in optics. Okay, there are a couple of different kinds of reflective situations. One is specular. Mirrors are specular, and what's special about them is they maintain order. When parallel light rays come in from an object, that order is maintained, bounces off with the same order. And that's why you can actually see images in a flat, shiny mirror. What if the reflector is rough? It creates diffuse reflection. We still have the law of reflection, so there's a normal. So like if a light ray comes in like, say, that, we still obey the law of reflection. But if a parallel light ray comes in and hits, well, maybe that's not the best example. Parallel light ray comes in and hits this surface. So I'm saying these two light rays are parallel. They're not going to bounce off parallel, are they? Because we're still going to obey the law of reflection. So the reflected ray is not parallel to the other one. And so we don't get an image. Can't see yourself in a rough surface. So again, the steps for sketching a reflection is to create this perpendicular, the segment that's a perpendicular bisector. Draw a line from the eye to the image, and draw a line from that intersection at the mirror back to the object itself. And you'll always get congruent angles. What we wouldn't want to do is draw something like this, because here we are flagrantly disobeying the law of reflection. These two angles here are not the same, and that's a problem. With a double mirror, we follow the procedure twice. We make a segment that is perpendicular bisector, and then we reflect that over the other mirror. Let me extend it. I'm going to extend the other mirror, and I can do a little better here. Okay, so we have another perpendicular bisector, And now I draw a line to this, and then back to here. There we go. So the line, in this scenario, the light bounces twice. And as I'm drawing this, I'm checking to make sure, again, that the angles of incidence and reflection are the same. That's some fun geometry. Okay, one more. Perpendicular bisector. This is a double mirror, so I'm going to extend. Oop, that's not the one I wanted to extend. I already did that mirror. Extend this mirror. Perpendicular bisector. And then the eye looks at the image. Go from this intersection back to the first image, and then back. So the light is bouncing like this. Oop. Light is bouncing from the object to the eye like that. All right, thanks for listening to that background information.